Assalamu alaikum. My name is Syed Sadasan. I'm from the Department of BS Biotechnology, and the topic of my presentation is half-life for first-order reaction. Half-life of a substance is the time it takes for a substance to decay to the one half of its mass, or in a reaction, it is the time it takes for a reactant to decay to one half of its concentration. Knowing the half-life of a substance is very important as it can help us control pollutants in the environment and also in the storage of radioactive material. For example, we can perform only those reactions in which the pollutants have low half-life so that they decay before reaching the stratosphere. That is, they don't affect the ozone layer. We are familiar with the rate constant K, and we know in a first order reaction, higher the value of a rate constant, greater is the consumption of the concentration in a reaction. Hence, there can be a relationship between them. Now, in order to find a relation between them, we will rearrange the given equation that my fellow has already explained earlier, which is ln a raised to a first a in a reactant a initial concentration over the a naught concentration. A naught concentration is the concentration in that specific time of a reaction is equal to negative of rate of constant into t. Now, if in this equation we will replace the value of t, or the depiction of t, with 1 over 2 to show that the value of t is actually the half-life. Here in the equation, t half-life is equal to ln2 over k. The value of ln2 is equal to 0.693, and this equation shows that as we have discussed earlier, that the greater the value of k, the shorter is half-life of the reaction. The above reaction that we have the above equation that we have shown that shows that half-life only depends on the rate constant and not the concentration, as it doesn't have any value for the concentration of that specific reaction at any time. Hence, it is only dependent on the rate constant. Now, showing graphically, we can see that whatever the concentration might be, the time taken for it to go to half of it is the same, i.e. it can start from a reaction from concentration 2 or from concentration 4 grams, but the time it will take to go to a half of it will be the same. Hence, half-life of a substance is independent of the concentration, and whatever the concentration will be, we start record whatever the concentration, we start recording the reaction. For example, we started recording the reaction at 50 grams. It will be considered its initial concentration, and after the time 1 over half, or half life, it will turn to its half, i.e. 25. Note that in the graph I have shown that after half-life the concentration won't drop to zero. Instead, for example, if the concentration turns half of the initial, then it will go 1/4 after second half-life and 1/8 after third half-life. For example, the concentration of a reactant is 100 grams when we started recording, and after one half-life it will turn to 50, and after the second half-life it will turn to 25, and after that half-life it will turn to 12.55555 and up to so on, i.e. the reaction after half-life, it after two half-life, it just doesn't go back to zero. Instead, it goes from 1 over 2 to 1/4 to 1/8 and up to so on. Concluding my discussion, half-life is an independent quantity of the concentration, but it only depends on the rate constant of the reaction. That's all from my side. Thank you.